Betelgeuse, the massive red giant on the brink of a cosmic explosion. Betelgeuse is a colossal red supergiant star. If it were placed at the center of our solar system, its outer edge would extend all the way to Jupiter's orbit. It's massive, highly unstable, and nearing the end of its life. When such stars explode, they release some of the most powerful bursts of radio energy in the universe, producing more energy than 1 billion suns. Are we ready for what might be coming? Betelgeuse, one of the closest massive stars to Earth, recently experienced a dramatic dimming event. This unexpected behavior has sparked global curiosity and a flurry of speculation in both the scientific community and the public. Some astronomers believe it could be a warning sign, a prelude to a supernova, the cataclysmic explosion that occurs when a star exhausts its nuclear fuel and collapses under its own gravity. Such an event wouldn't just be a visual spectacle. It would raise serious questions about its potential effects on Earth. Located in the constellation Orion, Betelgeuse is easy to spot in the night sky, known for its brightness and size. Often called Alpha Orionis, it's the most luminous and massive star in that constellation. Observations by NASA's Hubble Space Telescope and other observatories revealed that Betelgeuse ejected a significant amount of its mass in 2009, an extraordinary event for a star of its kind. While the Sun regularly undergoes coronal mass ejections, Betelgeuse's eruption was on a scale never before seen in a red supergiant, offering new insights into stellar evolution and end-of-life processes. Determining Betelgeuse's exact distance remains a challenge. Some estimates suggest it lies hundreds of light years away, with some placing it as close as 724 light years. Measuring distances to red supergiants is notoriously complex due to their immense size and variable brightness. Despite the uncertainty, one thing is clear. Betelgeuse is one of the brightest stars in the night sky, with a luminosity nearly 100,000 times greater than our Sun. But this brilliance comes at a cost. It burns through its nuclear fuel at an accelerated pace, rapidly approaching the end of its stellar life. When that happens, it could collapse and explode in a spectacular supernova, possibly leaving behind a neutron star or even a black hole. Could Betelgeuse pose a threat to Earth? While a supernova occurring just a few dozen light years away could have devastating consequences, Betelgeuse is likely far enough to avoid direct danger. Still, its explosion would be so bright that it could rival the luminosity of an entire galaxy, becoming the second brightest object in the sky after the Sun. It would even be visible during the day, and its light would cast shadows at night, an awe-inspiring but potentially alarming sight. The visible light from a supernova, while dazzling, is only a small portion of its total energy. Much more concerning is the high-energy radiation, X-rays and gamma rays, that accompany such an event. These rays can damage Earth's ozone layer, exposing the planet to harmful ultraviolet radiation and increasing the risk of mass extinction. Initially, the explosion would unleash intense radiation, but over time, a wave of cosmic rays, particles accelerated to near-light speed, will begin bombarding the solar system. These rays could erode the ozone layer and shower Earth's surface with harmful radiation for years or even centuries. Evidence from the Earth and Moon, such as deposits of radioactive iron, 60 in ocean floor sediments and lunar regolith, suggests our planet may have been exposed to such cosmic fallout in the past, possibly within the last few million years. While current astronomical assessments indicate that no known nearby supernova poses an immediate threat to life on Earth, ongoing research has revealed new potential hazards. In particular, some types of supernovae can emit deadly long-range radiation. One such scenario involves a dying star surrounded by a dense disk of material. When a star explodes, the shock wave heats the disk, releasing vast quantities of X-ray radiation capable of traveling long distances through space. The brightest X-ray supernovae could deplete a planet's ozone layer by up to 50%, potentially triggering extinction-level events within a radius of 150 light-years. Fortunately, no such supernova candidates have been found near Earth yet. But this possibility has led scientists to reevaluate the concept of the galactic habitable zone, the region in galaxies where life is most likely to thrive. It turns out the inner regions of galaxies may be too active and dangerous due to frequent stellar deaths, while the outer edges may lack the necessary elements for life due to insufficient star formation. The last supernova observed in our galaxy, occurred in 1604. Since then, we've only witnessed distant ones, such as the 1987 event in the Large Magellanic Cloud, 169,000 light-years away. While it was a landmark astronomical event, it posed no threat to Earth. Should Betelgeuse explode, it would offer an unprecedented opportunity to study a nearby supernova in real time. The event would likely dominate our skies for weeks or even months and remain a source of scientific research for decades. Until then, Betelgeuse continues to flicker, pulse, and dim, teasing scientists and stargazers alike with the possibility of witnessing one of the most powerful events the cosmos has to offer. Regions of the galaxy where stars form rapidly present unique hazards. Frequent supernova explosions in these areas can bathe nearby space in intense radiation, increasing the risk to any potential life forms that might exist there. Recent studies suggest that the inner edge of the galactic habitable zone is likely farther from the galactic center than once believed, reshaping our understanding of where life could most feasibly arise and endure. So, what might the Betelgeuse supernova look like from Earth? Fortunately, scientists believe Earth's biosphere will remain unaffected, but visually, the explosion will be impossible to miss. Experts predict that Betelgeuse will shine brightly for over 3 months after the explosion, reaching a luminosity about half that of the moon, roughly 9 times dimmer than a full moon. It will appear as a brilliant point of light in the sky, potentially visible even during daylight hours, casting shadows at night and captivating sky watchers across the globe. Remarkably, the supernova will remain visible to the naked eye for years as its remnants gradually fade. As scientists continue to observe Betelgeuse, they are gaining new insights into the life cycles of massive stars and the processes that trigger their explosive ends. Understanding supernovae is key to unraveling the history of our galaxy and the formation of elements. These explosions not only release light, but also forge heavy elements like gold, silver, and uranium through a process known as nucleosynthesis. The extreme heat and pressure of a supernova create the essential building blocks for future stars and planets. Interestingly, the aftermath of supernova, known as a supernova remnant, can serve as a stellar nursery. Over time, the dust and gas ejected during the explosion may give rise to new stars. This ongoing cycle illustrates the deep interconnection of cosmic events. The death of one star can lead to the birth of many others. Astronomers have identified remnants still forming new stars millions of years after the initial explosion, showcasing the universe's dynamic and regenerative nature. Supernovae also serve as crucial tools for cosmic measurement. Type Ia supernovae, which are the explosive deaths of white dwarf stars, shine with consistent peak brightness and are used as standard candles to measure vast cosmic distances. This technique has played a pivotal role in the discovery of the accelerating expansion of the universe and the concept of dark energy. Furthermore, studying supernovae can help scientists assess the potential habitability of exoplanets. Researchers are examining how the intense radiation from nearby stellar explosions could affect planetary atmospheres and influence the likelihood of life. Such studies underscore the importance of understanding the environmental factors that shape habitability across the cosmos. The idea of witnessing a nearby supernova also raises fascinating cultural questions. Historically, these celestial events have inspired myths, legends, and artistic interpretations. A supernova is not only a scientific occurrence, it's a profound symbol in human storytelling, often representing transformation, endings, and rebirth. In many traditions, the sudden appearance of a bright new star in the sky has been viewed as a sign or message from the heavens. Technological advancements have revolutionized our ability to detect and study these cosmic events. Space telescopes equipped with cutting-edge sensors capture detailed images and spectra, unveiling the chemical makeup and behavior of supernovae. Meanwhile, ground-based observatories play a critical role in monitoring such transient phenomena, allowing astronomers to respond swiftly and collect real-time data. Looking ahead, the future of supernova research is full of promise. With powerful new instruments like the James Webb Space Telescope and other next-generation observatories, scientists are poised to unlock even more mysteries about these stellar explosions and their far-reaching impacts across the universe. Scientists are poised to gain unprecedented insights into the life cycles of stars and the explosive events that mark their ends. These observations have the potential to revolutionize our understanding of stellar evolution and the fundamental forces that shape the universe. The study of Betelgeuse and its anticipated supernova serves as a gateway to broader discussions about how stars live, die, and influence the cosmos, from cosmic recycling to cultural impact. Massive stars like Betelgeuse offer a window into the violent yet essential processes that govern our universe. Supernovae, in particular, mark the dramatic end of a star's life while giving rise to new celestial structures. The remnants of these explosions can form nebulae, vast clouds of gas and dust that become fertile ground for the birth of new stars. Within these regions, complex chemical processes occur, often leading to the creation of organic molecules that are precursors to life. Moreover, the shock waves produced by supernovae can compress nearby molecular clouds, triggering a process known as triggered star formation. This chain reaction illustrates the interconnectedness of stellar phenomena, where one star's death can spark the creation of entirely new stars and planetary systems. In this way, supernovae act not only as dramatic conclusions, but also as catalysts for ongoing cosmic evolution. On a larger scale, supernovae play a crucial role in dispersing heavy elements throughout the universe. These elements, scattered across space, enrich the raw material from which new stars and planets are formed, ultimately influencing the chemical makeup required for life. This process of cosmic recycling underscores the vital importance of supernovae in astrophysics and deepens our understanding of the elemental origins of Earth and life itself.